Alrighty, this worksheet we're going to take a look at our different types of quadrilaterals, look at angle characteristics, side characteristics, and then at the bottom I need y'all to add, because I forgot to have this one in there. I knew I needed another row. We need to talk about the different types of symmetry that each of these shapes have. We need to talk about the different types of symmetry that these all have. Alrighty, so our first shape, what all these are all quadrilaterals. There is no one thing that is true for all quadrilaterals about their angles, except for the fact that all interior angles, interior means that they're on the inside, so all interior angles add up to 360 degrees. All interior angles add up to 360 degrees. So that means if I add up this angle, this angle, this angle, and that angle, if I add them all up, they will equal 360 degrees. This is true for all of these shapes. For just general quadrilateral side characteristics, there really aren't any for just a generic quadrilateral. So we're not going to write anything there. And then the symmetry, again, there's no one that fits there. It just depends on the shape. So we'll just write depends on the shape for these two. They might not have any symmetry at all. Remember, symmetry is when I cut something in half and it looks the same on both sides. So for example, if I try to look at this quadrilateral up top, it doesn't matter where I cut my shape, it's never going to be the same on both sides. So if I cut it down the middle like this, my left and my right sides, they're not the same. If I try to cut it down the middle like this, my top and bottom, they're not the same. If I try to cut it at an angle, they're not the same. They look kind of close, but this angle is small, that angle's big. There's no way that I can cut this shape and have it be the same on both sides. For trapezoids, the angle characteristics, like we've talked about before, they're going to add up to 360 degrees. Trapezoids, they can have up to two 90-degree angles. They can have up to two 90-degree angles. So if a trapezoid did, it would look like this, where this would be my 90-degree angle and this would be my 90-degree angle. This one up top, this one doesn't have any, but they can have up to two 90-degree angles. For their sides, they have one pair of parallel sides. The way that we show parallel sides is with these little pointy arrows. So having these two arrows show that these two sides are parallel to each other. If you have not done the vocabulary yet, parallel means that they're going to keep on going forever and ever and ever, and they're never going to touch. They don't have to, they may have one pair of congruent sides. Again, they may or may not. If they did, they would show you that by using those tick lines on those side two. If they have that one pair of parallel sides, that means they have symmetry. If they do not have sorry, not parallel sides, those congruent sides, then there's no symmetry. But if they do, that means that they would have vertical symmetry. That means it would have vertical symmetry. For example, like I said, this one, these two side lengths are the same. So its vertical symmetry would look like this. My left and my right sides of my trapezoid are the exact same. So that would be my parallel line. I'm going to draw a dotted line to show that it has vertical symmetry. Our next shape is a parallelogram. Like we talked about earlier, all these shapes add up to 360 degrees. All parallelograms add up to 360 degrees. Opposite angles are congruent. Opposite angles are congruent. So that means this bottom left corner here, its opposite is going to be this top right. They are congruent. They're the exact same measure. This bottom right, we're going to put two lines there because it's different than the other ones. So these two lines here, it's going to match up with this opposite angle. They are congruent, the bottom right and the top left. They are congruent because they are opposite angles. For the side characteristics, opposite sides are congruent. Opposite sides are congruent. So that means this little bottom side matches the top side. This left side here, two lines because it's different, matches the right side there, two lines. If the shape is cut with a diagonal, diagonal means it connects opposite corners. So if my shape is cut with a diagonal, those two triangles are the exact same. Those triangles are the exact same. Are they symmetric triangles though? No, they are not symmetric. They are congruent triangles, but they're not identical, so that means that they are not symmetric. So there is no symmetry. There is no symmetry for parallelograms. Now on to a rhombus. Sorry, I need to put my colors away so I can focus. So angle characteristics again, they're going to add up to 360 degrees. Like we had with parallelograms, remember a rhombus is a type of parallelogram, so the opposite angles are still congruent. Opposite angles are still congruent. So that means this top left is going to match up with that bottom right. The bottom left is going to match up with the top right. Make sure that you're not using the same number of little arches in your angles to show that the ones across are different. Alrighty. So, moving on to our sides of a rhombus. All sides are congruent. All of my sides are the exact same. They are all the exact same length. They are all congruent. Opposite sides are parallel. Oh, we forgot to add that on Rhombus or on Parallelogram too. Opposite sides are parallel. So again, we show parallel by using those arrows. So the left and the right are parallel to each other on both of these. And then also the top and the bottom are parallel to each other. I know it gets to be a lot, all these little lines on your shape, but it's really important to know what they mean. So I want to keep doing them every shape. A rhombus has two lines of symmetry. Two lines of symmetry. They are both diagonals. They are both diagonals. Again, if you haven't been to the vocabulary station yet, diagonal means that it connects opposite corners. So if I take a look and I cut along this diagonal, I have the exact same shape on both sides of my diagonal line, same square or same triangle. And then if I do it to the other diagonal, I still have two triangles that are the exact same. So again, we'll show that symmetry with using a dotted line. So we can see that there are two and that they are diagonal lines of symmetry. Next up, we've got rectangles. Rectangles, all the angles are going to add up to 360 degrees. Hopefully writing this so many times it'll stick in our brains. All angles are 90 degrees. That's what makes a rectangle special. Again, we show 90 degrees with using those little boxes in the corners. All of those angles add up to 90 degrees. For the sides, we have opposite sides are parallel. Opposite sides are parallel. So again, we draw those little arrows on my side lengths. One for one set of parallel sides and two for the other. Opposite sides are also congruent. Remember, congruent means the exact same. So my left side and my right side are the exact same. My top side and my bottom side are the exact same. For symmetry, again, we have two lines of symmetry. And they are again diagonals. These diagonals are kind of special because these diagonals are the exact same length. This diagonal, exact same length. On the rhombus, one of my diagonals was shorter than this diagonal. But on the rectangle, both of those diagonals are the exact same length. If you need a ruler to help you draw those diagonal lines straight, you can. Then our last shape, the square. What do you think all the angles are going to add up to? That's right, 360 degrees. And again, like a rectangle, all angles are 90 degrees. So we put those little boxes in the corner to show that it's 90 degrees. Opposite sides are again parallel. So the left and the right are parallel to the top, or to each other, and the top and the bottom are parallel to each other. All sides are congruent. So like the rhombus, the top, the bottom, the left, the right, they're all the exact same side length on a square. All the exact same. Like we had for the rectangle, they're still, oh wait, hang on, sorry, let me get back to that. The square, Andrea, I got excited, I missed something. The rectangle doesn't have 2 lines of symmetry. It has 4 lines of symmetry, oh my goodness. It has the diagonals, it has vertical and horizontal. Because if I take my rectangular shape, and if I cut it right down the middle, I have the same on the left and the right. That's vertical. Vertical is up and down. Horizontal. I cut it side to side, my top and my bottom are the same. So that means I really have 4 lines of symmetry on there. I need to add those dots in there. Sorry about that, guys. Oh my goodness. So rectangle has 4 lines of symmetry. So does a square. 4 lines of symmetry. Again, we have the diagonals, vertical, and horizontal. So again, diagonals, opposite corners. Vertical is up and down. Horizontal is side to side. Go ahead, pause the video if you need to catch up on any of those things. If you're good though, if you need to make some notes down at the bottom, I took a few. Again, vertical symmetry. Remember, vertical is up and down. Horizontal is side to side. And the diagonal, that's connecting those corners. If you're in my class, you've got one more thing to add. But if you're Mrs. Parada or Miss Lamphier's class, you can go ahead and end the video. You're good. But again, my students, we need to add in this word adjacent. We didn't have that on the vocabulary. I forgot about that one. Adjacent means side by side. Adjacent means side by side. And on some of these shapes, on a parallelogram, rhombus, rectangle, and square, sorry, y'all can't see that. On a parallelogram, rhombus, rectangle, and square, P, R, R, and S, adjacent angles add up to 180 degrees. So parallelogram, if I look at just those two angles, they add up to 180 degrees. If I do the side-to-side angles, those add up to 180 degrees. The same thing is true on a rhombus, on a rectangle, and on a square. So go ahead and add those extra notes in there if you need to. Otherwise, go ahead and go on to the practice for this.